In this video, we're going to determine symmetries, looking at a couple figures and identifying what types of symmetry does the figure have. So first we have this beautiful purple flower. Um, I look for lines of symmetry first, and then I'll look for rotational symmetries after that. So what I notice is first we have a line of symmetry that basically goes right through the center of that petal. The left side would map onto itself on the right. So we've got that line of symmetry. So let's just kind of make a couple notes off on the side. The line through the center of the petal is a line of reflection. So because we have 5 petals, I could focus on this next petal and draw a line of reflection through the center of that. And we could do that with each petal. Because there are 5 petals, we have 5 lines of symmetry. All right, because we have those lines of symmetry, we have, remember from our first video, reflectional symmetry. So this figure has reflectional symmetry because it had those symmetry lines that mapped it back onto itself. All right, now let's think through the rotational symmetry. So if we were to rotate this figure, well, I guess what we want to focus on or understand is all the way around completely is 360 degrees. So if we take that 360 degrees and divide it up, that will tell us a little bit about our rotational symmetry. So I'm actually going to continue to draw on these lines. So I think this helps us talk about the rotational symmetry as well. All right, I'm going to highlight a point on one petal. I think, oh, there it is, okay. So this point right there, we can rotate it around and I can tell that right here it's going to land back on itself. That whole thing will rotate and everything will be mapped back to itself. This will rotate another time right here, another time right there, another time right there, and then one last time. So we can see that there are 1, 2, 3, 4, 5 rotations of symmetry. So if we take that 360 degrees and divide it by 5, that's going to tell us how many degrees we rotated each time. 360 divided by 5 is 72 degrees. So we rotated 72 degrees and we mapped back to ourselves. We rotated another 72, mapped back onto ourselves, rotated another 72. So this flower has rotational symmetry. Actually, reflectional symmetry, we'll just make a note. There are 5 lines of symmetry, which I know we wrote above, but we're going to include that with our answer down here. Okay, rotational symmetry. When does this happen? This happens after 72 degrees. And then if we rotate another 72, we're at 144. If we keep rotating another 72, we get to 216. We rotate another 72, we get to 288. And then if we rotate that last 72 degrees, that gets us 360 degrees that we have rotated, and that's the one we don't include. So even though we divided by 5 to figure out how many degrees each rotation was, there actually are only 4 angles of rotation. Okay, next example, we have whatever this random thing is. These points are part of the figure. So if I were to draw a line through the middle of it, is this top part mapping onto the bottom part? Well, yeah, this part would map onto itself here. The green square would map onto the green square, but would the red dot map onto itself? And we can see there's no red dot right there. So that line of symmetry would not work. So this one's a little bit more complicated than we might have originally thought. So do we have any lines of symmetry? And you can just kind of look at it. If we have a line of symmetry here, that's not going to work. We already talked about that's not going to work. What if we went through our vertices? No, these red dots really are kind of keeping us. I don't see any lines of reflection. So we do not have reflectional symmetry. Do we have rotational symmetry? So could we rotate about a point in the center and map back onto ourselves? So this one we actually can. If we rotate 180 degrees, we can see that's lined up on a straight line through that point, that center of rotation. We do have rotational symmetry. And that angle of rotation was 180 degrees. If we go 180 degrees one more time, we get back to where we started, which is 360, and we don't count that one because we rotate 180 degrees. This figure has point symmetry as well.